Now that we've covered significant figures and how we count significant figures and why it's important to use significant figures, we want to look at the ultimate application of all of this as to how we actually use these in doing calculations. Significant figures are important because they allow us to show the reader of our data, the reader of our calculations, exactly the level of precision that was being used. Remember, all measurements contain both a number and a unit, and the level of precision of that measurement is determined based on all the digits we know plus the one that we estimated. Every measurement we work with contains exactly one uncertain digit, and we need to be able to keep track of where that uncertain digit is and not turn something that is very imprecise into something that's precise simply by doing a calculation in our calculator. The number of significant figures is equal to all the certain digits plus one uncertain digit, and we will round to make sure that there are the proper number of significant figures in each of our calculation answers. Our rules for rounding, the basic rules that we use for rounding: anything that is less than a 5 will round to the previous digit. So if we had 1.33, round based on the second 3, and we would keep it at 1.3. If the digit we're rounding based upon, the final digit, is greater than or equal to 5, we will increase the previous digit by 1, so we'll round up. So 1.36 rounded to 2 digits, 2 significant figures, would be 1.4. 3.2154 rounding to 3 significant figures, 2 after the decimal place, would be 3.22. So we round based on the 5, or round based on the 6, and round the previous number up. When we are doing calculations, it is important that you do all of the math and then round the final number. Do not round step by step unless the rule that you're using for determining significant figures changes during a calculation. You need to round before you start to the next type. So we'll see multiplication and division have a different rule from addition and subtraction. So if you're doing multiplication and division and then you need to do addition, round when you're done with the multiplication and division, then round based after the addition or subtraction, or vice versa. But if it's all multiplication and division, or all addition and subtraction, do the entire problem and then round at the end. The reason we're doing all of this is we cannot become more precise in any of our calculations by just doing the calculation. The precision of our data is determined on the recorded values that we did in the lab or that were given in a problem. So the first major rule for us: in multiplication division, the number of significant figures in the result must have the same number of significant figures as our least precise measurement. Let me underline that word because it is so important. Least precise. So whichever number has the least number of significant figures, that will be the number of significant figures that we can have in our final answer. So we will always round to the least number of significant figures from any given data. So here's an example. Suppose we want to find the area of a sheet of paper that is measured to be 3.12 centimeters on one side and 2.1 centimeters on the other. 3.12, remember the 2 here is an estimated digit. 2.1, remember the 1 is an estimated digit. So we'd multiply 3.12 times 2.1 and we get 6.552 out of our calculator. 3.12 has 3 significant figures. 2.1 has 2 significant figures. The answer out of our calculator has 4 significant figures. We need to round it to the least precise of our measurements. The least precise measurement is the one that has 2 significant figures, the 2.1 centimeters. So we will round our answer to 2 significant figures. So we'll look at our original number. We'll keep the 6 and the 5. We'll round based on the 5. So we round up. So we end up with a final answer, 6.6 centimeters squared. So let's look at a couple of examples. Press pause, try these yourselves, then press play again when you are ready to see the answer. Okay, in this first one, we have 0.0023 times 315. If I do that in my calculator, I get 0.7245. So the calculated answer, 0.7245 meters squared. Now I got to look at my significant figures. This first number has two significant figures, the 2 and the 3. Remember, these zeros are leading, so never significant. This one has 3 significant figures. So I have to go to the least number of significant figures, which is 2. So I'm going to keep the 7 and 2, round based on the 4. So my correct answer to this problem, 0.72 meters squared. The second one, a division problem. 3.58 divided by 0.025. Mathematically, in my calculator, the answer is 143.2 grams per milliliter. Units are very important. I must keep the units. Now I got to look at significant figures. This number has 3. This number has 2. These two zeros are leading, not significant. So once again, I have to round to 2 significant figures. So I keep the 1 and the 4, round down so it stays as a 4. I keep the 0 there to keep the decimal place. If I drop the 0, I would have 14, and 14 is not the answer. It's 140. So we get 140 grams per milliliter. This 0 is not significant because we did not put a decimal there. It is a trailing 0 without a decimal, so we only have 2 significant figures. You could also write this answer in scientific notation if you wanted to not worry about zeros. 1.4 times 10 to the second grams per milliliter. Scientific notation will work in all cases for writing the correct number of significant figures. You don't have to worry about zeros as much with scientific notation. Now, if we go to addition and subtraction, the rule changes. It's a different rule than what we had with multiplication and division. With addition and subtraction, we keep the same number of digits to the right of the decimal place as our least precise measurement. So whichever one has the least number of digits to the right of the decimal place, we'll round to that number of digits. So suppose we wanted to add 3 masses together, 4.24 grams, 8.1 grams, and 12.137 grams. When we add those in our calculator, we get 24.977 grams. We now look for the least precise measurement. This one has 2 places to the right of the decimal. This one has 1, and this one has 3. So we're going to go to the least precise, which is 8.1, which only has 1 number to the right of the decimal. So we need to round our answer so it only has 1 number to the right of the decimal. So we're going to keep the 9, round based on the 7. That causes us to round up. We end up at 25.0 grams. Here are 2 examples. Try them. Press pause here for a second. Then press play again and see the correct answer. Okay, in the first case, 23.4 plus 102.4 plus 0.003. We get 125.803 out of our calculator. Now we need to round based on the least number of numbers to the right of the decimal place. Here, 1, 1, and 3. So we're going to round to 1 decimal place, 125.8, round based on the 0. So we end up at 125.8. We're not looking at the least number of significant figures like we were for multiplication and division. We're looking at the least number of decimal places, numbers to the right of the decimal place. And the last one, 184.45 minus 94.45. This one comes out in the calculator to 90. Now, look at the number of numbers to the right of the decimal place. We have 2. We have 2. So our answer should have 2. So our correct answer, 90.00 meters. If we'd left it as 90 meters, we'd have been saying it was very imprecise, somewhere between 0 and 100, and we guessed 90. Here we're saying much more precise, somewhere between 89.99 and 90.01, and the estimate is 90.00. Key things to remember here. Multiplication division, we round to the least number of significant figures. Addition and subtraction, we round to the least number of digits to the right of the decimal place. Please keep these two things separate in your mind because these two different processes have two different sets of rules. Multiplication division, one rule, addition and subtraction, another.